these 5 factors, right? So we had given 5 value. So these 5 factors are here. And these are the individual that questions which we had asked, right? So now how to know which factor has loaded in MR2? So you have to see the value. N1, so if the value is greater than 0.6, right? 0.6 or greater than 0.6, so that factor would be loaded in the particular factors. In the MR2, N1 has been loaded, other has not been loaded, if you can see. N2 has been loaded, N3 has been loaded, N4 and N5 is loaded, but not that much, right? So what is that? These numbers are called the factor loading actually, right? So what about this number? This number is nothing but it's the correlation between the items and the factors. So here, how many factors we got? Actually we already assumed N1, N2, N3, and N4, and 5 are the same nature of the question. So that's why these 5 has been loaded over here, if you can see, right? And you can ignore N5 because N5 that factor loading is not very less, but yes, it is less. So it is up to you. If you want to remove it, you can remove it. It's not a problem at all. MR1, so MR2, we got the factor. If you have any question, you can ask, right? It should be 0.6 or greater than 0.6. MR2, if you can just see the value, E2 has been loaded. You can see E1 is also loaded, but not that much, but you can take. E3 is loaded, E4 is loaded, E5 is loaded. As we already know, these E1 is are the same kind of the factors, right? But here you can drop which one? You can drop E5. MR3, let us see. Yes, this is C1, C2, C3, C4, C5. So that C1 is not good loaded, so you can drop it here. You can drop this one is also. MR5, you can see A1 you can drop. A1 is not significantly actually loading over here. A2, A3. A2 and A3 is good loaded. A4 you can drop. A5 is not good loaded. You can also drop it, but if you want to take it, it's not a problem at all, right? But it is always suggested if the value is 0.6 or greater than 0.6, you have to take that value. But if you are taking minute differences there from the 0.6, you can take it. It's not a thumb rule, right? MR5, if you can see. So O1, O2, O3, O4, O5. If you can see O1, O2, O3, O4, and O5. This. Again, only O3 is good loaded, but others are not good loaded. So you can remove it. Other numbers, so only O3 you can take from here. Okay. So this is only this matrix is important. Others are only cumulative variance. Variance is there, then proportional exponent. So commonality I already explained to you. Commonality is nothing but it's a common variance, means the same kind of the variance which are explained by the factors. Now please tell me if you have any question in factor analysis understanding, please tell me within 5 minutes. If you can just ask some questions, then I can go further. Is it fine? Should I go further? Okay, in the factor analysis, if you have any question, you can ask.
Sir,
Yeah.
do
Yes.
we need both factor analysis and principal component analysis?
Can you speak again? It's echo is there.
Sir, do we need to run both factor analysis and principal component analysis?
Principal component analysis and factor analysis both. So yeah, so actually principal component, yes, factor analysis and the principal component analysis both are the different things. right? But generally, when we decide about the factors, that how many factors are there, we generally use principal component analysis, right? If you can just see, let me just show you again this figure. So this figure is not only on the basis of principal component, but it is also on the basis of factor analysis, right? So that red lines are for the principal component and factor analysis as well. So what we have taken from the factor analysis actual data. How many factors are coming? 3 factors are coming. From the principal component actual data, how many factors are coming? 6 factors are coming. So that's why I have just merged both of the thing here, right? It is up to you. If you want factor analysis only, you can take only 3 number. You can just use 3 number over here. But it is always advisable if you can just to check the principal component, because principal component is a good analysis which is giving if the eigenvalue is 1 or greater than 1, you can count that factor, and that number of the factors are the principal component of your data. So yeah, both are the things are possible. It's not a problem at all. So but it is only about the deciding the factor, nothing else. I'm sure you got the answer. Any other question? Should I move further? Now, how to do the analysis, right? That is the question. So factors, so we got the factors. So if you can see these many factors are there, right? We have loaded the values as well. Now I want some unique variables. So how many variable I want? MR2. लेकिन MR2 में कितने load हुए हैं? If you can just see N1, N2, N3, N4, N5, 5 variables has been loaded, right? So for making is one variable, what you have to do? Name, how will you give the name? So suppose this n1, n2, n3, n4, n5 is a suppose quality variables are there, right? q1, q2, q3, q5, like this, right? So you can give, because this quality variable has been loaded in this factor, so you can just give this factor name as quality, and like that other factor name you can decide over there, right? So now okay, fine. Now you have to just take 4 variable only. So how to do it? So we have to transform all the factors. So after this, you have to give factor transformation. Factor transformation, right? So for the factor transformation, you have to just make it as dot data dot frame, because your data should be in factor form, then predict and your FA, factor analysis. So when you just run it, what is the problem?
So actually data is missing from the chart. Data name is missing.
Yeah. Just a minute.
So can we take a break? So for 10 minutes?
Okay. Makes sense. Yeah.
Okay, sir. Thank you so much.